Uh, Yesterday we had covered the basics about the cloud computing concepts, right? Today we're going to see few more important topics. And yesterday we covered what is SDLC and what is the infrastructure maintained by the organizations and the issues that you are facing from the infrastructure like capital expenditure and operational expenditure. We have seen that and what is the solution to that cloud computing and what is cloud computing? Cloud computing is the on-demand delivery of IT resources over the internet, which you call as virtually in a pay-as-you-go model, right? So, example of the cloud computing service providers, we know we have the AWS from Amazon, Microsoft Azure from Microsoft, GCP, Google Cloud Platform, IBM, Oracle, etc. So, these are all the top cloud computing service providers. But apart from all, Amazon Web Service is playing a very leading role. It's a global leading cloud computing service provider. It is not saying by me, it is as per the report. As I have shown you the report, Gartner report 2021, which is the latest, saying that Amazon is a top in the leaderboard, followed by Microsoft Azure. So because Amazon has the flexibility, even the services, it has almost 200 plus services it is providing to the customers, to the end users. So we're going to see why it has become the global leader, what is the history, and what is the infrastructure. We're going to see that. But before going to see that, today we're going to discuss three important topics, three very, very important topics. It might be a potential questions for your interview or else for your examination. If you decided to write global certification exam, Amazon Cloud Practitioner exam, or Amazon AWS Solution Architect Associate exam, if you're going to sit in that exam, which is a global valid exam certification, so there they will ask these questions, these topics, which we're going to discuss today. This might be important potential questions in that point of view, even in the interview also. So let me put in the whiteboard about the important topics that we're going to discuss today. And once again, before going to the topic, I want to remind you all that we started the batch from yesterday. Yesterday is the day one, right? So you are under AWS and the DevOps. Okay, we're going to deal with the AWS tools and also the DevOps tools, right? Training by me, Mr. Sai, so which is a batch number 199, right? If you are interested to get register into this course, you can scan this QR code for course content or for registration process, right? Every day it is morning 8 o'clock, 8 a.m. to 9 a.m. Indian IST, okay, Indian Standard Time. Yes, definitely, Nikhil. The thing is that what are the classes? See, that's why I recorded, right? The recording is in progress. Okay, so that's why what are the classes we are recording here? So what are the classes we are recording here? You can access from the LMS portal. Okay, they will provide one LMS portal to you. Okay, I think it is lifelong. I think lifelong you can access the recording classes. Only the one who registered into these classes. Okay. I think lifelong they can access the recording access they have. And also at the same time, I am also providing this dumb. Means what are the PPTs that I am providing? All right. See, this PPT is prepared by me. Okay. So such materials also I am providing from my side. Okay. Such materials I am also providing from my side. So overall, you can access the recording classes, right? And also the materials. So this is what we do generally. Even the previous batch, okay, even they were very they enjoyed a lot with my classes. Okay, so these are things. So any doubts so far? Any queries? Can you inform to your friends? Can you inform to your friends who are ready to upskill themselves in the AWS and the DevOps from my side, from me? Okay, please kindly intimate to your friends because I think the registration will close very soon. I think next 2 days. Okay, the slots will close. If you have any general information, if you need any general, see all the sessions recording, you can see here all the session recordings and notes will be accessed through LMS graphic. Okay, you will provide one portal. Okay, you will have one portal where you have to register there, and you can access all the materials, everyday recording classes and everyday materials. Right. So that is a thing. Okay. So if we go to the today's class, if you go to the today's class, any doubts, any queries where I can clear you to further clarify you. I hope everyone is comfort, doing good. Great. Thank you. So let me go for the today's class. So today's class, we're going to discuss important topics. Let me put here virtualization concept. We're going to discuss what is the virtualization, and we're going to see cloud deployment models, cloud service types. And if you have the time, we're going to see the shared responsibility model. So these are the things that we're going to cover today in the recordings. As I told you, Latif, as I told you, recordings are provided to you. The recordings are provided to you from the management team, admin team. Okay, personally, I am not going to share. Personally, I am not going to share you. Currently, the class is recording, right? Currently, the class is recording. So the admin team, what they will do immediately, they will post in your registration account. Okay, once you register into these classes, okay, immediately they're going to post, update, upload in the registration account that we call as LMS portal. Okay, in that portal, you can access the recording classes, all the recording classes from the day one, even the yesterday's. Okay, so that is what. So yes, recording classes why we are providing, because at the end you have to revise, right? You have to revise because you are listening now. After that, you have to revise. You have to make notes out of that. Okay, you have to get prepared for your own self. So that's why recordings are provided to you. You can access at any time and update to your friends as well who are ready to join, who are ready to learn from me. Please kindly update them as. So now we're going to discuss these topics for the day. So any doubts in yesterday's topic? Any doubts, any queries from yesterday's topic? As we discussed SDLC, how the project is working, standard operating procedure, and we have seen the issues. We discussed about the issues, and later we discussed about the cloud computing. If anyone not joined yesterday, please kindly go through the recording class where you can see, you can go to the website, Logic Labs Technology. Yes, you can do this. You can also go to the website. Only, I think you're going to access only 3 to 4 recording classes if you are not registered. See, if you go to the Logic Labs Technology, in this website also you can access, you can see my name like batch number 199. You can see Core Java Pythons. See AWS DevOps. You can see AWS and DevOps starts on 12th September. Okay, from Sai. Okay, if you want, you just go here, the demo registration. You can see here the recording classes. After registration, I think after registration of the things, you can see yesterday's recording class, you can see here. Okay. Yesterday's recording class, I think you can see here. Okay, this is the recording class yesterday's. You can see from here. Okay. That is the thing. You can watch from here. Right? So if you register here, you can access regularly. That is the thing. Okay, fine. So coming to the topic. So what is the concept of virtualization? Because we know cloud computing. What is cloud computing? On-demand delivery of IT resources over the internet. So how they are delivering the IT resources over the internet, right? Physically, they are not coming to our homes whenever we requested. Physically, they are not coming to our homes to deliver the IT resources. But they are saying that we are providing through the internet to you. We are providing all the IT resources to you over the internet. How it is possible? So that is the concept we're going to understand. Okay. The concept behind that, we're going to understand with the virtualization. So virtualization is acting like a foundation of cloud computing. Okay. It is acting like a foundation. Virtualization concept, it is a concept. Okay. To implement this concept, we are using the tools. Okay. It is a concept or else it is a technology we call as. To implement this concept, to implement this process or technology, we are using the tools like hypervisor, VMware, etc. Okay, so this is a concept which is acting as a foundation of cloud computing. If cloud computing service providers are there, it is because of virtualization. What does it mean? Okay, it is meaning that it is a foundation for the cloud computing. Now we will discuss what is a virtualization exactly. What is a virtualization exactly? We'll discuss what is this concept. What is the concept behind this virtualization? So we know this is, let's say, this is our computer or our machine. Okay, let's say this is our machine. It may be a laptop or computer, anything. Inside this machine, if you see the hierarchical way, where the hardware, okay, we are calling it as hardware components. What are the hardware components we have? CPU, RAM, hard disk. Upon that, we have the operating system. It may be any operating system. Okay, Windows, Unix, Linux, CentOS, Ubuntu, Mac, Red Hat, etc. Okay. So upon the operating system, okay, we are using the applications. We are running the softwares. Right? This is what we know. Okay, this is what we know. If you see the PPT, my PPT slides, where I prepared for you. So this is what we know, right? So these are hardware components like CPU, RAM, and hard disk. And upon that, we are using our operating system. And these are all the softwares. These are all the softwares or computer programming, okay, computer program or applications that are running upon our machine, right? That are running upon our machine. Now see here, this application, let's say it is Amazon. It's Amazon software. This is a Facebook. Okay, let's say it's a Twitter. Okay, etc. Now this Amazon application, when you install this Amazon application, okay, this application requires 10 GB hard disk. Let's say, suppose this application required 10 GB hard disk. Okay, when we are installing this software, it is taking 10 GB hard disk from our local machine to store the program files, to store the software files. And if we execute this application, if we run this application, it is taking like 4 GB RAM. It is required 4 GB RAM and 2 core CPU capacity. CPU is calculated in the form of cores. Okay, what do you mean by core? It means you can say like that one performance at a time. Okay, it means that is a capacity. It means if it is 12 core means it is almost like 12 performance at a time. Okay, because CPU is a processing, so performance it do certain processing. So let's say this Amazon application alone, this software alone, it is taking 10 GB hard disk, 4 GB RAM, and 2 core CPU. From where it is getting? From our underlying, right? From our underlying hardware, from our machine hardware, right? So similarly, let's say Twitter is also taking certain kind of resources, okay, certain kind of resources. It means we are allocating. It means see here, if you observe, all the applications commonly they are depend on the hardware. They are depend on your hardware. Okay, let's say here in my hardware, let's say I have the 12 core CPU capacity and 8 GB RAM. Okay, and let's say 100 GB hard disk. It is my laptop configuration, hardware configuration. So what are the softwares I'm running here? What are the softwares I'm running here? All the softwares are has to share, right? All the softwares has to share these resources, right? But one software is requiring high capacity and another software is requiring low capacity. With that, what happening? So one of the software is becoming very inefficiency. We are unable to perform in one of the software because of the limitation in the resources. Because of the limitation in the resources. I think it's making sense. Because if you're running all the applications at a time, if you're running all the applications at a time, and one of the software is unable to take the resources from the hardware because already remaining softwares are taking the resources. required resources. And the last, which is the last at the bottom, it is unable to take the resources because all the resources are ended up. So the performance is very low. Okay, the performance or the software performance is very low. Did you notice any time when we are trying to install any softwares, when we trying to install any software, it is sometimes, did you feel that please kindly remove remaining softwares? There is no enough space. Did you notice any time? There is no enough space. Please kindly delete existing softwares, which is not needed. Then only we can install the software, right? So in the same way, because all the 10 to 15 applications are dependent on our underlying hardware. Okay, they are the conflict. They are the conflict in between them to get the resources. To get the resources. So let me show in the graphical way. Because of this conflict, okay, because of this conflict, because this is a limitation, we cannot share more than this, right? This is a limitation. All the applications has to adjust within this. Let me show one example, like a task manager. Have you seen the task manager in your local machine? Anytime did you notice the task manager in your local machine? If you see the task manager, you can come to know which application is running in the background and what is the CPU capacity it is taking. Okay, how much RAM it is taking. Let me show you the task manager. See here, if you observe this task manager in the background, so these are the applications I'm running and how much CPU it is taking each application, each software, and how much RAM it is taking. Right, what is the disk page? What is the networking? You can see all the things. Okay, you can see the things. All the applications commonly depend on the hardware. All the applications commonly depend on my hardware. Okay, depend on my hardware. So now we might face sometimes the inefficiency. Okay, inefficiency in performing the application, inefficiency in running the application. So that is why we have the concept called virtualization. If you read this document, virtualization, what in the scientific way it is saying that virtualization is a process. Okay, virtualization is a concept or the process that allows for more efficient utilization of physical computer hardware. I think it's making sense. So virtualization is a process which is allowing us, which is allowing us for more efficient utilization of physical computer hardware. And this process is also acting as a foundation of cloud computing technology, foundation for the cloud computing service provider. So what we are doing, what exactly this process? Let me show you. Okay, let me show you here. So with this process, what we are doing here, so it is saying that virtualization is the efficient utilization of physical computer hardware, right? Efficient utilization of physical computer hardware. What are the hardware in my physical computer? Okay, CPU, RAM, hard disk. They are the physical computer hardware. So with this concept, I am going to use these resources very efficiently. How it is possible? Yes, it is possible because of virtualization. So upon the operating system, what I'm doing, I'm installing one software. Okay, I'm installing one software. Okay, let's say VMware or hypervisor. We are calling it as tool. Okay, so this is a software we can call it as tools. Because of this tool, using the software as a tool, okay, we're going to implement this virtualization concept. Are you getting? Now, virtualization is the concept, and we are to implement this concept, we are taking the support from the tools. Hypervisor is the tool, which is software. Okay, by installing that hypervisors, what we are doing, we can create the virtual machines. Did you notice my point? I'm saying that virtual machines. What do you mean by machine generally? When we call the machine, when it has the hardware, okay, when the machine has the hardware, when the machine has the operating system, and when we are running the applications, we call it as machine, right? When we call, okay, just similarly like this, when we calling the machine, when we calling a particular thing as a machine, when we have the hardware, when we have the operating system, and when we are running the applications upon that, so in this combination we are calling it as machine. So what I'm calling it as, we are calling it as virtual machines. So virtual machines, it means it is overall it is a machine but it is virtually located. It is a virtually located. It is not physically we are creating. It is not physically we are creating inside the machine itself, inside the host machine itself. Okay, inside our main machine, inside our main laptop, we are creating virtual laptops. It means virtual machines. Okay, how the hardware, how the hardware it is come to here? It means we are allocating. Kindly focus my terms. We are allocating or reserving. We are allocating or reserving our hardware resources to the virtual machines. Okay, upon that, we are installing our own software. Okay, we are installing our own operating system and we are running our own applications. Let me put you that PPT in the visualization mode. See, upon our hardware and upon the operating system, we are using the virtualization layer, which is acting like a abstract layer. Okay, this virtualization in this concept, we are using the software as a tool. Okay, why we are using the software? Yes, Saranya. Saranya, you are welcome to talk. Saranya, what is your doubt? You may unmute and talk.
Sir, am I audible?
Yes, yes, you are audible.
Sir, in our computer system, whatever the hard disk we are having, the same thing is we are allocating, right?
Yeah,
So,
same thing. Not fully we are allocating. Let's say your application, what are the software you require? Let's say you're allocating, you're predicting, okay, it is better if you allocate 10 GB hard disk to this virtual machine and 2 CPU capacity and 3 GB RAM. So independently, it will become a one machine inside your computer. And upon the hardware, you can install your own operating system like Linux, Ubuntu, etc. Upon that, you can run the application perfectly, efficiently.
okay, because we are using the same hard disk, and then might be it will be having the same memory, while partitioning also.
Yes, yes. Well,
How
partitioning of yes.
efficient?
So what exactly about Serena?
Actually, what you said, sir, no, that if you are running more than four application, if we are like memory is full, that time that another application don't have the memory. Now, actually, if you do the partitioning also, if you run the same four application, again the memory issue only will come. No.
Yes, yes. No, no. Saranya, the thing is that it doesn't mean that four applications, if we want to install fifth application, means we are allocating the resources to the applications efficiently. Let's say Amazon required 10 GB, 4 GB RAM. Okay,
Okay.
Amazon, okay, every time Amazon required 4 GB RAM. So we are allocating the 4 GB RAM to the Amazon. Are you getting? We are allocating that resources to the Amazon to perform very well. So it means the application performance. We are focusing on the software performance in a good manner by
Oh,
sharing our resources efficiently, by using our resources efficiently.
so we should be knowing which application is need which much, how much memory that we should know before.
Yes, yes, yes. Before that,
Okay.
right? So
Thank
which application is required? How much resources required for which application? Because to perform well, okay, to operate that application in a proper perform well. So we are allocating that resources to the application. And what is the limitation? We cannot do beyond our hardware, right? We cannot do beyond our hardware.
you. Yes.
Yes, that is the thing. Yes, yes, Saranya. Okay, that's the thing. Sure, it's clear, I think.
Yes.
Yes. So anyone, any doubts? Anyone, any doubts? Okay. So what happening here? If you see this diagram, okay, if you see this diagram, so earlier what we done, all the applications are commonly running, and they are depend on our physical hardware. Okay, or CPU, RAM, and hard disk. And here it is a quite inefficient way we are using our hardware. Inefficient way we are using our hardware because we don't know which application using how much RAM, okay, which application is using how much CPU processing, right? So in that way, what we are doing, we decided it is not proper. It is better if we use our physical hardware efficiently. If we use our physical hardware efficiently. Did you notice anytime you have the 8 GB RAM? Let's say you have the 8 GB RAM in your laptop. Do you think that you are using the 8 GB RAM every time, guys? Did you notice that? Are you going to use the 8 GB RAM every time? We don't know, right? So that is why what I decided, I want to allocate this 8 GB RAM to the application level. Okay. And also my hard disk also. I want to allocate this hard disk also to the softwares in a proper way. And also the CPU capacity. Right. I want to allocate these resources to the required softwares. Exactly. So that to do this possible, we are using the hypervisor concept. Okay. We are using the virtualization concept in the form of hypervisor. Okay. So now we are ready to allocate our physical hardware to here. Now we have the hardware. Upon that, we can install any operating system. Right. Upon that, you can install any operating system. Let's say your laptop hardware, your laptop operating system is Windows. Let's say you have your laptop with the Windows operating system. But once you've done the virtualization concept, once you've done the virtual machines, okay. So inside this machine, already you allocated certain amount of physical hardware, certain amount of physical hardware. So upon that, you can install any operating system that we call as guest operating system. Okay, you can install Linux, or else again you can install the Windows, or else Ubuntu, etc. You can install any operating system. So upon that, you can run the applications. See, now this application is now this complete operating system. Complete operating system is depend on the application, right? Now this application is having a communication with the operating system. It's independent operating system. Are you getting? Now this application have the independent operating system and its independent resources, right? This application have its own operating system and its own physical, like own hardware resources, which is virtual hardware, because we are allocating this hardware from the physical hardware, right? So then it is a very chance, very better way this application will perform very well. So that is the concept of virtualization. That is the concept of virtualization. So like this, you can clear multiple virtual machines, but what is the limitation? You cannot go beyond the your physical hardware components. You cannot go beyond the physical hardware components, right? Like this. So every application have its own operating system and own virtual hardware. So then your application will perform very well because it has its independent operating system and independent hardware. Okay. Upon your main computer, you have the multiple virtual machines. Okay. I hope the concept is clear. Virtualization. Anyone? Yes, Saranya. Saranya, you are allowed to talk.
So it's clear.
Yes. It's clear to you? Yes. Good. See here, if you read this, I'm going to share this material also. Okay, don't worry. I'm going to share this document also. See, using this virtualization concept as a process where we are taking the support from the software, right? This is the process. This is the tool to implement the process. So with this process, with this software, what we are doing, we are creating an abstract layer, right, over the computer physical hardware. So with this, what happening? We're going to allocate. Okay, we're going to allocate a reserve, our computer, CPU, RAM, and the hard disk. Okay, to the multiple virtual computers. Okay, to the multiple virtual computers, which are acting, which are calling it as, which we are calling it as virtual machines. Okay, because why we are calling them virtual machines? This virtual machine have its own operating system, right? And also the hardware that we are allocated. So with this, we can call it as independent computer, right? We can call it as independent computer, which is running on your underlying computer. Okay, underlying computer. So with this, what happening here? So we are using our hardware resources, our physical computer hardware resources more efficiently. Okay, more efficiently, right? So it means you are doing justice. You are doing justice to your hardware components. Let's say your laptop have 8 GB RAM. So you are allocating that 8 GB RAM to the virtual machines, creating the virtualization layer, and you are allocating that 8 GB RAM. Let's say six out of 8 GB RAM, you are allocating 6 GB RAM, 6 GB RAM to the independent machines. So right. So in this way, you are going to use your resources very efficiently. You're going to use your resources very efficiently. Out of let's say 100 GB hard disk, okay, you are keeping 30 GB hard disk for your local machine and remaining 70 GB hard disk. And virtual hardware have the same configuration. Yes, same configuration. What does it mean when you say we cannot go beyond our physical hardware? Yes, yes, dear. See here. Let's say what I mean to say here. What I mean to say here. Let's say your hardware. Let's say your physical computer hardware. It is 16 GB RAM. Okay, your laptop is 16 GB RAM. Okay, 16 GB RAM. And out of 16 GB RAM, what you done? 4 GB RAM you kept with you for your laptop. You kept 4 GB RAM for your laptop. Okay, for underlying operating system processing. Okay, and remaining 12 GB you decided to allocate. You decided to allocate. Let's say okay, 1 GB RAM to here. Okay, 2 GB RAM to this virtual machine. 3 GB RAM to this virtual machine. Okay, 3, 4, 5, 6, 7, 8. Okay, 9, 10, 11, 12. Like this you allocated. Can you go beyond that? Can you create any another virtual machine? Can you create any another virtual machine? It's not possible, right? Because we don't have the RAM to allocate. Yes, that is what I mean to say. We cannot go beyond our underlying physical hardware. We can allocate the resources, but we cannot jump beyond, right? There's a limitation also. I think it's clear to everyone. That is a virtualization concept. Okay. So this is the same concept. This is the same concept we are using for the cloud computing service providers also. Let me show you how. Let me show you how. Okay. If you understand this concept, we're going to implement this in the cloud computing. What happened yesterday? I told you. We know what is cloud computing? On-demand delivery of IT resources, right? It is delivering the IT resources over the internet. It is delivering IT resources over internet. So now what happened here? Let's say example of any cloud computing service provider. Let's say AWS. So what happened? AWS physically they constructed one building. Inside the building, what they done? They installed. Okay, they deployed big computers. Lot of big computers, big resources, CPU, RAM, etc. Okay, upon that they use the concept called virtualization. These are hardware, CPU, RAM, hard disk. These are all the things are hardware. Okay, let's say in this big building we are called as data center, physically located building. Inside this data center, what they done? They install the hardware. Upon the hardware, there came with the concept called virtualization. Now, what is the virtualization? With the virtualization, we can use the physical hardware efficiently. Right? What is the virtualization? What is the virtualization? It is an imitation of the hardware, right? It is replication of the hardware or else imitation of the hardware. We can call it as, see, it is imitating the hardware. Okay, your hardware resources. Okay, it is imitating your hardware resources. So what AWS has done, okay, inside the physical building, data center, this building we are called as data center. Inside the data center, the AWS had installed lot of hardware components. Okay, they purchase lot of infrastructure and they install in the data center. From here, we going to get, let's say this is me. Okay, this is me. I am in front of my laptop, let's say. And here what I'm doing, I went to the AWS website. I went to the AWS website. And inside the AWS website, I'm creating my virtual machine. It's making sense now? I'm creating my virtual machine. How I'm getting my virtual machine? How I'm getting my virtual machine? From here. Let me go here in the need page. Let me draw one diagram. Right. Let's say it's a AWS data center in one of the physically located building. Okay, it is a AWS data center, physically located building with the infrastructure, with the resources. Okay, we call it as host computer. We call it as host computer. And they are the hardware resources, right? CPU, RAM, in the hard disk. So AWS also what they done upon the hard disk, we have the operating system, as you know, and upon that, AWS also installed the virtualization layer. Okay, AWS had also installed the virtualization layer. So with this virtualization, what we can do? Efficient utilization of physical hardware resources. Efficient utilization of physical hardware resources. Now let's say this is me. Okay, immediately I need one laptop. Okay, immediately I need one virtual. Immediately I need one machine to perform the task, to run my applications, to develop the application. So instead of purchasing the laptop, what I can do, I can go to the AWS website, right? I go to the AWS website here and I can create the virtual machine. It means where I am creating the virtual machine inside the AWS in one of the data center. Okay, now I am creating the virtual machine upon this. Let's say here I'm selecting the, okay, let's say here I'm selecting, okay, I'm giving the requirements. I need 2 GB RAM. Okay, I need 10 GB hard disk. Okay, it is a hard disk. Okay, and I need Windows operating system. What are the requirements I have given? Okay, now this host computer going to share here. It is going to share 2 GB RAM, 10 GB hard disk, and upon that, it is ready. It is getting ready with the Windows operating system. And now our virtual machine is ready, right? We have the hardware, we have the operating system. Now we can use this machine for our applications. We can develop the applications, we can run the applications, software. Do you agree? Now let's say another person also coming. He also need one virtual machine from his laptop. Okay, he also going to create his virtual machine. Okay, virtual machine 2, like virtual machine 3. Now it's clear to everyone how we are getting the resources over the internet from the cloud computing service providers. It's clear to everyone, guys. It's clear to everyone. So now this virtualization is acting like a foundation for any cloud computing service provider. It may be Azure, it may be GCP, it may be AWS, etc. Right? This is how the AWS is providing the resources to us. Now I think the concept is clear. Now what is cloud computing? On-demand delivery of IT resources over the internet to the users. Okay, if you need any laptop, if you need any machine immediately, you can go to the AWS website or Microsoft Azure or GCP. You can get the virtual machines. How it is possible? Already, the cloud computing service providers, they invest a lot of money. Just here, if you see the data center, you can come to know. Yeah, let's say AWS data center. How the data center looks like. See the images. See, inside the data center, which is a physical building, okay, physically located building. Inside the data center, you can see all the resources, infrastructure. See how it is. See, this is a building. Inside the building, okay, inside the building, they install all the resources from, okay, and from here it is going to supply to the users. How? Through the virtualization concept. It is sharing its resources. It's clear now? It is sharing its CPU, RAM, hard disk, etc. to the customers with the concept of virtualization. I hope it's clear to everyone now. Any doubts? Any doubts? Let me wait for 1 minute, or let me take your doubts, your queries. Let me know till if it is unable to understand you, please let me know. I'm happy to explain once again because this thing should be clear. Okay, this thing should be clear, right? So virtualization is the concept of allocating the physical hardware into multiple components of the same physical hardware. But see, buddy, yes, it is allocating the physical hardware. But once you allocating the physical hardware, again it is becoming one more machine, independent machine. Are you getting my point? Upon the allocation of the physical hardware, you can install the operating system. And you can run the application softwares. Yes, within the same physical hardware only, within the same physical hardware only, you are creating multiple machines. Yes, Nikhil. So with that allocation, you are creating multiple machines. So that machines we are calling as virtual machines. Yes, once we allocate, then it becomes a new machine. So that machines we are calling as virtual machines because inside your physical computer, you are creating one more machine, which is virtual machine. Right. So in the same concept, all the cloud computing service providers, even they are allocating the resources to us. So when you require any resources, even the cloud computing service providers from the data centers, even they are allocating that resources to us with the concept of virtualization. Okay, now we can go and create the virtual machines upon their physical computers, upon their physical host computers. That is what happening. Yes, that doesn't depend on the physical computer. But see, But how it is possible? Only with the virtualization layer, right? Only with the virtualization software, the tool. Do you agree, Nikhil? Only it is possible with the virtualization layer. Let me show you my PPT. See here, this virtualization also, here we are using the hypervisor as a tool. Okay, this is software we are using. Okay, this is a software layer we are using to implement the virtualization concept. To implement the virtualization concept. Now it is acting like an interface. It is acting like a layer between the virtual machines and the physical computers. Between your virtual machines and the underlying physical hardware. Right? And ensuring that each has access to the physical resources. It needs to be executed. It's clear, buddy? It's not, we can't say that it is completely independent. Okay, your virtual machines, what are the resources we allocated? Okay, it is interacting with your hardware. Okay, if you need 2 GB, you can give 2 GB. If you need 4 GB, you can allocate 4 GB. It means there should be some interaction. How it is possible? With the virtualization layer. Okay, with the virtualization layer, acting as an interaction between the virtual machines and the underlying hardware. Right. So here also this hypervisor software, if you talk about the hypervisor software, okay, this software is of two types. Okay, this software is of two types. Sometimes in the interview they will ask, okay, what are the types of hypervisors? You can see there are the two types of hypervisor. One is the type 1 hypervisor and one is the type 2 hypervisor. If the software, if the virtualization software, this hypervisor, if it is directly running upon the hardware, if it is directly running upon the hardware, then we are called it as type 1. See here, the hypervisor that runs directly on the host hardware to control the virtual machines. Then we are called as type 1. Or else we can also call it as bare, a bare metal hypervisor or native hypervisor. So which is runs directly on the host hardware. Then what is the type 2? Type 2, if you observe the type 2, it is running upon the operating system. Okay, you are creating the virtualization layer upon the operating system. Okay, if you are creating the virtualization layer directly upon the hardware, then it will become the type 1. If you are creating the virtualization layer directly upon the operating system, then it will become the type 2. Okay, the hypervisor layer that runs on the operating system of your computer, then we are called as type 2. Okay, which runs on the operating system. Just like other software applications. Okay, these things you should know. There are two types of hypervisors. One is the type 1, which we call as bare metal or native, and one is the type 2, which is directly running upon the operating system. Okay, it is a level of virtualization. Yep, it's clear to everyone. Any doubts here? Anyone? Any doubts? Any confusions in the concept still? I hope it's clear to everyone. Fine. So once if it is clear to everyone, okay, please kindly don't hesitate because it is our class. Okay, you are free, you are welcome to ask the doubts because we are here to upskill ourselves, right? So don't hesitate. You can ask me, you can ping me, you can do chat, or else you can open your mic if you want. If you want to talk, you can raise your hand. I can allow you to talk, right? Don't hesitate because it is our class. I'm happy to help you out, right? So if you understand this concept, virtualization, this is the foundation of the cloud computing. Now further we'll move for the topics of the day. Okay. Now, what is the cloud deployment models and what is the cloud service types? We're going to discuss this too. Okay, we're going to discuss these two things. Now, what is a cloud deployment model? It is sometimes they will ask in the interview or the questions in the examinations. Cloud deployment models. Generally, we have the four types of deployment models. I will tell you what are all. What are the four types of deployment models? We have the public cloud, we have the private cloud, we have the hybrid, okay, community cloud. Let me discuss one by one. Okay, we have the four types of deployment models. One is the public, private, hybrid, and community. So let's say what happened, my organization, let's say currently I'm working in one company. In that company, what they done, Okay, in my organization, okay, in my company, what they done, instead of purchasing the infrastructure, okay, instead of purchasing the infrastructure, okay, instead of investing the money on the infrastructure, physical hardware, okay, instead of government cloud. What is meant by government cloud? Okay, yes. Okay, buddy, yes. Government cloud is nothing but, I will tell you, uh, even see government also, even if you know, if you see this, even the government is providing the services, right? Over the digital, over the digital way, government is also providing lot of governance, like lot of services, what we call as governance. Okay, government is also depend on the softwares nowadays to provide the services. So to provide the services by the government over the softwares, okay, it means the government also requires certain infrastructure, right? Certain infrastructure. Instead of okay, okay, I will discuss in the meanwhile. I will discuss this. I'll come to there. So now let me finish this example. You can understand. Okay. Now in my company, my organization, what they are, instead of purchasing the physical hardware resources, listen carefully, my terms. Instead of purchasing the physical hardware resources, they are taking the physical hardware resources from the cloud computing service provider. They're getting the physical hardware resources from the cloud computing service provider. So my organization choose an AWS. My organization choose an AWS. Okay. And my organization completely depend on the AWS for the infrastructure. Or you can say for the resources. So what are the things we have, what are the data we want to deploy? We are deploying in the AWS. Okay, we are deploying in the AWS infrastructure. Okay, we are deploying in the AWS infrastructure. This AWS will become the public cloud because this AWS is open to everyone. This cloud is open to everyone. Anyone can access and anyone can deploy the resources. Anyone can choose the resources and deploy the data. Are getting? Because this public cloud, this infrastructure and the resources, it is managed by the AWS in the background from the data centers. Okay, it is managed by the AWS in the background from the data centers. So this type of cloud model, this type of deployment model, we are calling as public cloud, like AWS, Azure, GCP, etc. They are all the public clouds. Okay, where everyone can access the resources, infrastructure, and they can deploy the data. And what my organization done, they not deployed all the data. My organization also, what they done, in my organization, we have one more data center, our own data center, my organization data center. Are getting now? What is the data center? With all the physical hardware components. With all the physical hardware components. Okay. So what are the confidential information we have? What are the confidential project data we have? We deployed this data in our local data centers. Okay, which is on premises. On premises. Right. Only it is access to my organization only. Only this on premises data center, these resources can be used by the organization only, this particular organization only. So this type of cloud model, this type of deployment of cloud model. Okay. And here also we are creating virtualization layer, right? Let's say it is CPU, RAM, and hard disk. Here also we are creating the virtualization layer. And with this virtualization layer, all the organization people can access from the laptops. Okay, all the organization people can access from the laptops and they create the virtual machines in the laptops and they can access the data. Right. So this type of model we are calling it as private cloud, which is a on-premises private cloud. Okay, which is more secure, right? Because it is under the control of the organization. Okay, the virtualization layer and the underlying hardware and who going to create the virtual machines, it is completely under the control of organization. So which is on premises. Okay, which is on premises. Okay, now, buddy, someone had asked what is the government cloud? Let's say it is under the government. Let's say this cloud is under the government. We can call this government cloud. Okay, we can call this government cloud. But where you hear this term, buddy? Where do you hear this term, government cloud? If the government is managing that, okay, just like the AWS, which is a public cloud, anyone can access. If the government is managing that cloud and the data centers and virtualizations, it called as government cloud, just like the private clouds. I hope it's clear, dear. First time. right? So it's a public cloud and it's a private cloud. Okay, now see my organization. If you observe, now I think you got what is a public cloud deployment, what is a private cloud deployment. Now what is a hybrid? So my organization, what they done? So what are the okay 50% data, okay 50% application. Okay, let's say we are running one software. We are running one software inside the AWS infrastructure, and we are keeping the database within our data. Okay, we are keeping the database related to the software in our data center. Okay, which is on premises. So this type of combination, okay, using the public cloud and the private cloud. So this type of combination we are called as hybrid model, right? This type of combination we are called as hybrid model. It means I am using the AWS infrastructure and also my on-premises infrastructure, my on-premises cloud, which is private cloud, and also at the same time I'm using the AWS cloud as well. So this type of combination we are called as hybrid cloud. Okay, hybrid cloud or hybrid model. It's clear to everyone now what is a public cloud, private cloud, and hybrid cloud. Anyone? Any doubts? You can see the. Let me show you. You can see one here. Types of deployment models in cloud computing. See, you can see here. See, the cloud infrastructure is operated solely for an organization, right? See, which is on premises. Okay, which we called as that type of model we are called as private cloud. If it is a public means it is managing by the like cloud computing service provider, which is in general, like which is in public way, right? The cloud infrastructure is made available to the general public or a large industry group and is owned by an organization. Here, what is the organization? AWS, right? Because they are sharing the resources to all the people, okay, group of people or to all the people in general, right? So that type of cloud we are called as public cloud. If your organization have its own cloud, its own infrastructure, which is managing by its organization itself, that type of cloud we are called as private cloud. So if you use both the combinations, if you're using your on-premises and also the public cloud, that type of combination we are called as hybrid cloud, right? It is a combination of composition of two or more clouds, okay? Two or more clouds, right? Then what is this community cloud? What do you mean by this community cloud? Let me put one example. Let me put one example. Let's say we are the banking. We know everyone know in India we are the HDFC Bank. In the HDFC Bank, all the banks need infrastructure, right? All the banks need a lot of infrastructure. Okay. Let's say in Hyderabad, okay, in Hyderabad, all the six branches, let's say six branches, example only, six branches came together, and they want to create one cloud. They want to create one cloud to share the resources among them. So now the six branches become the community. Six branches become the community because they decided to set up the cloud and to share the resources among them. It might be the public cloud. They can create the resources over the public AWS, or else they can create their own on-premises private cloud. It's clear to everyone what is the community. So when the group of people come together, when the group of people come together to set up the cloud and to share the resources among them. Now it's clear to everyone what are the deployment models we have: public cloud, private cloud, hybrid cloud, and community cloud. Any doubts, guys? Any doubts? Any doubts here? Because this thing is very important. I've seen a lot of questions, a couple of questions in the cloud practitioner in the examination, cloud practitioner examination. Okay. Even they had asked such type of questions. Okay. What is the deployment model? Okay. These things. Sometimes in the interview also they'll ask. Okay. They want to check your basics, whether you understand that, whether you have the concepts in the basics or not. Okay. That is the thing. I hope it's time up because it's time up. So just now I showed you, or you can go here. You can go to the website like Logic Labs Technology. Go to the website for Logic Labs Technology. Go to the website here, and you just search for courses. Under the courses, you can see 199, batch number 199. This is the batch number 199. upcoming batches or ongoing batches. Okay, you can search like this, or else you can go to the home page. In the home page also, if you drop down, just now I've shown you. See, we are here. Okay, we are here. See, Logic Lab Technology, AWS and DevOps start on 12th September yesterday, 8 a.m. to 9 a.m. Okay, for a couple of days. Trainer, Mr. Sai. Okay, myself Sai. Okay, this is a course fees. You can buy there. Okay, by clicking that, I think you can buy from here. Right. Say it is yesterday's recording class, and today's recording class also you can go into access from here. And here you can launch your graphic. Once you done the payment and all, once you done the payment, I think you can create your own graphic. You can create your own portal. Okay, you can create your own portal. Okay, enter your name, email ID, and that you can access the account. Okay, you can access the account. Clear? So that is the thing.